Example number 29, evaluate the integral 2 over x squared square root of 1 plus x squared dx. Now, anytime you see a root in the denominator, such kind of roots when algebraic substitution, when you are not able to eliminate it using the u substitution, then they are always hyperbolic or trigonometric functions. Are we together? So if you see you have something like 1 plus x squared, that is a case of a Pythagorean identity. When you have, in Pythagorean identity, when you have sine squared t plus cos squared t is equals to 1, isn't it? That is the first. The second one, if you divide root 2 by cos squared, you get tan squared t plus 1 is equals to sec squared t. So it means when this x is tan t, when x is tan t, when you say x is equals to tan t, you can see tan squared t is going to be x squared, isn't it? So it means x squared plus 1, where there is tan t, you put x squared plus 1. So it means x squared plus 1 is going to be the same as x squared t. Then if you have square root of x squared plus 1, which is the same as 1 plus x squared, isn't it? Square root of that, you get square root of sec squared t. But square root of sec squared t, square root goes with square, you remain with sec t, isn't it? Are we together? And remember your x is tan t, but what is now x squared? Meaning x squared is tan squared t. Are you seeing that? X squared is tan squared t, isn't it? Then go on, ladies and gentlemen. So if x is equals to tan t, what is the derivative? If you differentiate x with respect to t, what do you get? You get dx over dt to be equals to, if you differentiate x with respect to t, if you differentiate tan t, you get sec squared t, isn't it? So if you differentiate tan, you get sec squared. Yes. That is a standard differentiation. So if you take dt the other side, you remain with dx is equals to sec squared t dt. Are we together? Are we together? So from here, what have you found? You've let, from here, we've let x to be equals to tan t. Then we found that if you differentiate x with respect to dt to t, dx over dt is sec squared t. If you take dt the other side, you get sec squared t dt. Then at the same time, if you substitute here, what have we found? What have we found? Go on. We found this. So what is x squared? X is tan t, meaning x squared is tan squared t. Then what is square root of 1 plus x squared? We found it is square root of 1 plus tan squared t, isn't it? Which is square root of sec squared t, which is sec t. Are we together there? So multiply them. X. Can you now multiply them? X squared times square root of 1 plus x squared. What do you get? X squared is tan squared t, isn't it? Then square root of 1 plus x squared is sec t. You are done with that. Then what do we want? We want 2dx. We want 2dx over x squared into 1 plus x squared. This is what we are looking for, isn't it? Are we together? See, in the numerator we have 2dx. So it is 2 times dx. But what is dx? Dx is sec squared t dt. Dx is sec squared t dt, isn't it? Isn't it? Over x squared into root of 1 plus x squared, you found is tan squared t sec t. Can you now simplify that? Look at this. 1 sec goes with 1 sec in the numerator, you remain with the 2 sec t dt. In the denominator, you remain with the tan squared t, isn't it? You remain with tan squared t. So from there is what you simplify further. Here it means you have 2. What is sec t? Sec t is 1 over cos t. Meaning instead of sec t, it is cos t in the denominator, isn't it? But tan squared t is the same as sin squared t over cos squared t. So it means cos squared t comes back in the numerator. Are we together? Then your dt, which is there. This sec t is 1 over cos t, which you place there. Then this tan squared t sin squared t over cos squared t, meaning cos squared t goes back in the numerator. Are we together? So from there you have 1 cos t cancels out with 1 cos t, you remain with the 2 cos t dt over sin squared t. So you have 2 cos t dt over sin squared t. So that is now what you use. It means this integral is the same as 2 cos t dt over sin squared t. So what do? You let sin t to be something else. Let sin t to be y. So if y is equal to sin t, if you differentiate y with respect to t, if you differentiate in t, you get cos, multiply both sides of the equation by dt. So you get dy is cos t dt. So look here. So here we have the integral of 2 is a constant, you factor is outside. Then cos t dt is the same as dy. Have you seen that? Cos t dt is the same as dy. So where there is cos t dt, you put dy, 2 is a constant, you factor is outside. Then out denominator we have sin squared t, but sin t is y, meaning we have over y squared. So this means we have 2 integral of y raised to negative 2 dy. Because when it is in the numerator, it means it is raised to negative 2. So that is a case of a polynomial, isn't it? That is a case of a polynomial. So there you get 2. If you integrate y raised to negative 2, it is negative 2 plus 1 over negative 2 plus 1. Then at the end you add c. So what do you have? Negative 2 plus 1 is, see that is negative 1. Negative 2 plus 1 is negative. So 2 divided by negative 1, you get negative 2. Then y raised to negative 1, it means it is over y. So negative 2 over y plus c is equals to negative 2 over y. But what is y? Y is sin t. So it is negative 2 over sin t plus c, which is equals to, what is sin t? What is t? What is t? Look at that. My friend, x is tan t. So what is t? T is tan inverse of x. Because x is tan t, so t is tan inverse of x. So it means where there is t, you put tan inverse of x. So it means this is negative 2, sin t is sin of tan inverse of x. Then at the end of integration plus c. You're done. So it is negative 2 over sin of the tan inverse of x plus c. Very simple. So if you are given the limits, you simply put in the limits to get the definite integral, isn't it? Very, very simple.